In this very short talk, I would like to present an ongoing initiative which is aimed at creating a safety-related profile for ONNX. So basically, our objective is to clarify and possibly to complete a subset of the ONNX standard in order to support its use in safety-related systems. So we have proposed the creation of a work group to the ONNX steering committee. If it is accepted, we plan to do the kickoff after the summer break in late September. So my presentation will be very short. I will briefly present the rationale behind the creation of this work group. I will describe what we plan to do, and then how we plan to do it. So what I would like first to give you is a short introduction about ourselves. So we are a small group of experts, basically on specification, design, VNV, and certification of embedded real-time systems. And we work for different major industrial companies, including Airbus, Thales, Embraer, Safran, and several research institutes, including the CEA in France, INRIA, RT Saint-Exupéry, and Systemix. So basically French companies except Embraer. And currently the group's expertise is focused on real-time systems. Okay, oops. On real-time systems, and more specifically real-time systems for the aeronautical domain. But most of us have already been working about trustworthy AI for several years now. And I just want to mention that one of us is involved in the international EuroCAE SAE WG114 working group, which is developing a standard for recommendation for the usage of AI in aeronautical systems. So, and this person, Christophe Gabreau, is the chairman of this international work group. And in order, maybe you see the screen or maybe not, I don't know, I can't see. I have provided with you with a list of reference should you want to have a look at what we have done so far and how we have managed to address the issue of trustworthy AI up to now. So the first question is to be clearer about our needs. It's really a mess on my side. I don't understand what's going on. So to embed an ML component in a safety-related system, everything must be done in order to be confident in its capability to deliver the expected service. And in particular, we have to take care about the development assurance practices, which must be applied during all the development and the complete lifetime of the systems, and also including VNV and so forth. And if we consider machine learning, it concerns all the activities, including the development of the data set, the definition of the operational design domain, the design and the training of the ML model, its implementation, its deployment, on several type of hardware, including processors, GPUs, and so forth. And in this work group, focus is placed on the implementation phase, and more specifically on the capability to ensure that the implementation of the trained model is actually correct with respect to its specification. So for this to occur, to ensure this property, there is a prerequisite, which is that the ML model must accurately and precisely describe what is to be implemented. So this obviously means that the formalism that is used to describe the model must itself be sufficiently accurate and precise. So we have many different frameworks, APIs, or format to describe ML models, but we have considered that, but considering the user base and the number of tools and the support that we have, with ONNX, it was the best starting point and the best choice. I would just want to mention several regulation requirements. So having a clear and precise specification is an obvious. What's going on? Is an obvious requirement for any system, but in particular, when you are dealing with regulation requirements, where you have to stick to demonstrate that you comply with those requirements, and in particular, the one in the aeronautical domain, the one that I've already mentioned, the RRP. And if we have a look at the RRP, they have proposed a W-shaped cycle where the ML model plays a central role, and so the ML model description formalism plays also a central role. And there is this short sentence you may see or not, I don't know, which states that the ML model description should contain sufficiently details on the ML model semantics to fully preserve its semantics in the implemented ML model. So the ML model is clearly a central point in the process. So what are the challenges for our ONNX? Okay, so in order to obtain this accurate and precise description, we have to work on the two aspects of any language: its semantics and its syntax. And considering the semantics, we have to consider the operators and the graph, and have a clear definition of what they do for all the possible data types, for all the subset of the data types that consider useful. And up to what level of details and mathematical formalization we will go, it's still an open question, and we will address it during the first sessions of the work group. So in order to make things slightly more concrete, I would just want to give you a few examples. So they are not maybe the best examples, but I will give you a taste of what we were trying to do. If I take, for instance, the convolution operator, what we can find in the documentation, is a very short description of its semantics, or what it does. I'm really sorry because the slides are moving independently of my will, so I don't know what's going on, and I don't know how to stop them. So that's a pity. So what I was trying to explain is that if we look at at least one operator, this is just an example, the convolution, there is a short description within the which simply says that the convolution basically does a convolution. And to be able to implement the convolution from this definition is a bit complicated. So really, we really need something more, something that will be either an informal but complete description, or a formal description, and possibly both. And I have given the example of what we can see in the NNEF documentation, which is slightly more precise and probably complete. I don't know, but this is something we are trying to, we will try to do. Yeah, so this is something we want to do, to be a little bit more expressive, explicit on what the different operators do. And you can move to the next slide. And we want to do the same thing about the graph semantics. We have to expose what is the semantics of the graph, how the things are executed, in which order. And it might be the case that for some applications, we want to specify exactly, precisely in which order the operators must be executed. Just because considering that we are using floating point operators, there might be some non-determinism, and we want to avoid this non-determinism by specifying in which order the operators must be executed. So this could be part of the standard of the profile too. And you can move to the next slide. And we have to do that for all the different data types. And we may also have to have a look to the meta model, the ONNX meta model, and its concrete syntax, its format, and to check that there are no ambiguities, that everything is clear, and so that if one takes the model, the ONNX model, it can interpret it without any degree of freedom. Everything is completely specified, and there is no degree of freedom, and you can implement it, and n person can implement the same model, and we obtain the same result. So next slide, please. So we are on slide 14. So besides this completion of the definition of the ONNX model, we also have to consider other features that may be useful in order to ensure traceability between one model and, for instance, a refinement of the same model. So this is not required with respect to our main objective, which is to have a clear specification for the implementation, but it may be useful to support all the development activities. So this is something we will try to look at also. Next slide, please. So what is the work plan to obtain these results? Next slide. We will have three main activities. The first activity is aimed at capturing the needs of the end users, of the industrial end users, and translate these needs into requirements for the safety-related profile. So we want to answer to two different questions. What do we need exactly? And once we have defined what we need, what do we require from ONNX? And once we have done that, we will analyze the ONNX standard, or at least a subset of the standard, and the definition of the subset will be also a task to be done by the work group. And we will identify what needs to be clarified, what needs to be completed, and what needs to be possibly corrected. I don't know. I do not expect anything to be corrected, but we will at least ask ourselves this question. And the third step will be to develop the safety-related profile. That is to say, to write the description of the operators, to write the formal description if we consider that having a formal specification is necessary. And so the deliverables will be divided into three groups. In the first group, we will have this definition of the need, the definition of the scope, what are the operators that we want to put into this profile, and we will consider the use cases of the industrial partners in order to identify, to determine the scope, and we will write this requirement specification. The second deliverable will be the identification of the things that have to be improved in ONNX for the defined profile, for the scope that will be defined in D1.B, and the third deliverable will be the profile itself. So the next steps, the work group creation is ongoing. As I said in the beginning of the talk, we have two chairs, Jean Suiris, which is online, and myself, Eric Jen. The first meeting, the kickoff meeting, will be planned by during the end of September after the summer break, and the agenda will be provided by then. And the modalities, they have to be defined, but basically meeting every 2 weeks with the reports of the activities of the different work groups, the monitoring of process, and so forth. But the business as usual, I would say. So here are our two email addresses. So if you're interested by this initiative, if you think that you can provide some insights, we actually need some insights on ONNX. We are, as I said at the beginning, we are expert in the development of aircraft systems, and we are not necessarily expert in ONNX, so we really need some expertise in that domain. So please don't hesitate to get in touch with either myself or Jean. And that's it for me. If you have any question, and I'm really sorry about what happened during the presentation, but I was not expecting this, and usually it works, but yeah, as usual, when it should be working, it doesn't work. Thanks.
Thank you for your presentation. I had a question around profiles. You said something about safety profile. What do you mean by that? And is it, how can it be optional? Because not everybody would have need for the features that you are going to eventually propose.
That's the reason why we defined a profile. I mean, we are not addressing any type of applications. We are focused on those that require some very strong evidences about the development process. So this will be a subset of ONNX. And so the people, there is an echo. It's practically impossible to speak. So the people who have some concerns about safety will use this profile. The people that have no concern about safety will use ONNX as it is today. So it's really focused on the most demanding usage domain. But what we want to do is we do not want to modify we do not want to have an impact on the usual user of ONNX. What we want to do is to incrementally identify additional information to be put that are useful for people working in the safety critical or safety related domain, but it will have no impact on the rest of the world. And second, the documentation of the operators, the formal description of their semantics, these have absolutely no impact on any other user. It's just documentation. So they can just live with the standard documentation. If it's okay for them, that's fine. But if they want to have something extremely not extremely precise, but sufficiently precise, then they will use the profile. I don't know if I answer your question. It's very difficult for me to speak because I have some echo.
No, you did. I think we need to ponder, and I guess once you have your work group set up, that would be the right place to to think more and brainstorm on how the concept of profile will be done. So thank you for your presentation.
Thanks a lot.
Thanks for the presentation. You mentioned something about traceability on around page 14 or something. I was wondering if you can say a little bit more on what that means.
I was considering that in the usual case, you take your ONNX model, so the one which represents the specification of what you have to implement, and then you will refine it. So you may decompose or fusion some operators. You may some internal transformation from ONNX to ONNX. And what could be interesting, I would not say that this is something mandatory. That's what I said during the presentation. It's not mandatory, but to be useful, to be able to embed within the model the relation that this model has with another one, where the initial one, the one that you have refined. So how this can be implemented, I don't know, but this is something. The traceability is something we need. Do we need to embed this traceability information within the ONNX model, or have something else outside that will relate the operator from one model to the operators of the refined model? That's a question. Probably, maybe it's a bad idea to embed this within the ONNX model itself. But it's something we have to think about, and the same applies for the documentation. Documentation is not something mandatory, but giving some information about the meaning, for instance, of a tensor. What does this tensor means, or what does the dimension of the tensor this tensor means? This could be something useful, not with respect to the implementation, but with respect to the interpretation and possibly the validation activities that will come afterwards. So all these things have to be clarified with respect to the actual needs of the end users. So we have, for the moment, we have just started discussing, thinking about it, but we think that there might be something to be done to ease the development process, not to guarantee anything, but simply to ease it. So these are two aspects of the work that we want to do within the work group. But the main objective is the first one, is to have a clear, accurate, precise, complete specification from which you can do your implementation. So that's the main goal. Does it answer your question?
Yeah, that sounds great. Thank you.
Yep. Thank you, Rick. We can, for further questions, the contacts will be shared and participants can reach out to the speaker. Thanks for the talk, Eric.
Thank you. Bye.